Hello my friend, you are welcome to my channel. This video is a part of our ongoing generative AI video series. So as of now, if you have watching my previous video, as of now we are learning perceptron model, and in my previous video I have discussed very detail about what is perceptron model, how it works, right? Now going forward, we are going to learn about the training part, how the perceptron model, how the training happens in the perceptron model. And for the training part, I thought to create two videos, and this is going to be the first video. And in this video, I will more talk about the graphical or geometrical intuition of the training, how the training happen. Let us understand graphically how the perceptron model works graphically just to train it model. Okay, so this video will be the first part of training where we will discuss about graphically how the training happens and what are the core concepts behind that. Okay, so let's get started. Let's understand how the training happens graphically or geometrically in perceptron. Today topic is about training. Okay, what is that? Training of perceptron. How to train perceptron model. And this video is very important. If you really want to understand the perceptron, how it works, is very important. Okay, so let me recap what we had covered in our previous video. I had covered that we have one neuron. Okay, and let's suppose I have two inputs, x1, x2. I have two input. Let's suppose I have a salary, I have a city. Okay, and the purchase will happen or not happen. This is what we covered in the last video. Let's suppose salary is 2, city is 1, purchase happen. Okay, and let's suppose salary is 3, city is 2, purchase not happen. I'm just giving a hypothetical data set. Okay, so if you know that if the input coming, okay, suppose this is my input, it will connect to this neuron, this will connect to this neuron, and we have to assign some weight w1, w2, and we have to give some random bias. Okay, and here it will do the summation, it will perform the calculation, and it will perform some action, step function, and it will predict the output. This is what we have seen. Okay, so what we write here mathematically, this is what happens. Let's suppose I'm taking the first input. Let's suppose I'm taking 2 1. This is my first input. Okay, let's suppose I'm feeding this input 2 1 into my model. Okay, so my input is 2 1, 2 comma 1. This is my input, and my weight here is w1, w2, which is random, I have assigned, and my weight is b. Okay, so with respect, it will perform this calculation, right? 2 w1 plus w2, 1 into w2 plus b, right? And then upon that we have to apply a step function f, and then it will produce outcome. Okay, let's suppose it comes 0, right? So you can see that for this input 2 1, for input 2 1, my prediction is coming 0, right? But here my actual value is 1, so it's a misclassification, right? So in previous video I told that if there's a misclassification like this. Okay, so what happens, it goes back. Okay, and it will update my w1 and w2 and b. There will be update happen in this weight and bias, because my output, my prediction is not matching. Okay, and then it got updated, and this happens in iteration way. It happens in for all the rows. Okay, whenever there is a mismatch happen, it will go back, it will update. If there is no mismatch happen, then it will do nothing. Okay, there is no update happen. This all I have covered in my previous video. Okay, right? So now in this video we want to understand that exactly how this weight w1, w2 and bias, how exactly they got updated. What is the rule behind updation? Okay, it is called update rule. Okay, if you search on internet, it is called perceptron perceptron update rule. Okay, so this is what we are going to learn in this video. What are the process behind updating the perceptron of our weight and bias, how to update it. This is what we are going to cover. Okay, Now, so before we explain about it, how to do the update, I want to explain you some concepts. Okay, before I will come to that point, but before I come to that, let us understand some concept. Okay, so guys, please pay attention here. It is a bit concept. It's a kind of graph, or you can say it's a math concepts. Okay, so let us understand this concept first. Okay, let's suppose okay, let's suppose I have same data set. Okay, suppose I have salary data set, and I have a city, and I have a purchase happen or not happen. Okay, let's suppose I am taking 4 rows. Just to explain this concept, I'm taking 4 data set, 4 observation. Okay, for this input, suppose purchase happen. I have some random value. Okay, suppose purchase happen. For this input, purchase not happen. Okay, and for this input, purchase happen. For this purchase not happen. I'm just giving some random value. Okay, let me plot this. I'm I'm drawing one graph here just to explain this whole concept. Okay, my line is not straight. Let me put a straight line. Okay, guys, my handwriting is not good. On paper it is good. Okay, so this is my x-axis and y-axis. Okay, let's suppose this is my x-axis, y-axis. Why I'm taking x and y? Because I have 2 inputs, because I have only 2 features. Why I'm taking 2 features? Just to explain my concept. It's easy to explain in 2 dimension. 3 dimension, 4 dimension is a little bit difficult to understand. Okay, so I have 2 dimension x and y. Okay, and let's suppose it's a bit graphical concept. Okay, so let's suppose I have a line. This is a one line. Okay, and I have 2 points. Okay, let's suppose I have this point. I'm plotting one point here, this point. Okay, which is below the uh, you can see in the last video I discussed that straight line create 2 regions. Okay, you can see that there are 2 regions. One region is above the line. These are the above the line regions, and these are the below the line region, right? So let's suppose this point falls below the line. Okay, let's assume that for time being. And there's another point which is in red. This red point is falling above the line. Let's suppose I have 2 setup. Okay, now let's suppose by mistake. So actually, ideally, this is the actual rule or actual things, that my blue line, okay, my blue line is always below the line, and my red point is above the line. This is the rule. Okay, but let's suppose by mistake this blue line, which is supposed, again I'm saying that this blue dot, this blue point is supposed to below the line, but by mistake, let's suppose this blue line, one of the blue line is misclassified, it is above the line by mistake. Okay, again for the red point, it is supposed to happen that red point is always above the line, but by mistake, let's suppose this red point is below the line, which is not expected, which is not should happen. This is my setup. I have 4 points. Okay, so here one thing I want to uh, explain. Let me change my color. Okay, so let's focus on these 2 points. Okay, first first this point and this point. Okay, so let's suppose this is my straight line. So this straight line is what? Nothing but it is w1 x1 plus w2 x2 plus y plus b. Okay, this is the straight line, right? I hope you have seen my previous video. Okay, so this is my prediction basically. Okay, so here this point and this line. Okay, this point is above the line, I mean it is my prediction. Okay, so this point, suppose it has some coordinate, it suppose it has, suppose anything, I'm just giving 2 3 any coordinate. Okay, so this point is above the line. Okay, so it's a prediction, and actually in my data set, let's suppose this one. Okay, this is this one. Okay, so by prediction this is above the line, and also actually it should be above the line. I mean, this is what I'm trying to say. Let's suppose y predict. Okay, and y actual, both are same. Okay, so according to y actual, it should be above the line. I mean, it is, suppose it's a purchase. Okay, suppose this reason is a purchase reason because it's above the line. Okay, and below the line, this reason is not purchase. So let's suppose this is my two reason. Okay, so this point, let's suppose this purchase happen actually. Okay, suppose actually purchase happen, and according to my line, according to prediction, it is also predicting purchase happen. Okay, in this case, if both are same, okay, if y predict and y actual, okay, if y predict and if y predict equal to y actual, so this point is representing this case. I mean, my prediction is saying that it purchased because it is above the line, and y actual is also saying that it is purchase happen, so both are same. Okay, in this case you can say that there is no error, right? So my prediction and actual thing both are same. Whatever is the actual, exactly my model is predicting. It means there's no error. This is the same. Okay. So this point is supposed to be purchase reason, which is actually predicting my model. Okay. Now think about second, this dot. Okay. So why predict? Because this line is below my this reason. Okay. So why predict is saying what? Y predict is saying that it is not purchase, and let's suppose actually it is not purchase, right? So in this case also, my y predict and actual y are both same, so even in this case there is no error, right? So these two line, this line and these two lines has no error, so my prediction and actual thing both are same. So according to line, it is saying that my prediction is purchase, and let's suppose it is purchase happen, no error. This line, it is saying that according to prediction, according to line, prediction is saying that purchase not happen, and it is actually not happen. So there's no error. Okay. Okay. Now think about this line, this point, this point. Okay. This point is saying that according to line that y predict, what the y predict is saying, purchased happened, right? Because this point is above the line. So according to line or according to model, according to prediction, purchase happened, but actually purchase not happened. Let's suppose it's a zero. Actually purchase not happened. So in this case, what you observe that y predict and y actual are not same. I mean, in this case, something error or misclassification happened. So this point represent a misclassification. My prediction, my line is saying that, I mean, my prediction is saying that it is purchased. But if I compare with the real data, it is saying it is not purchased. So it's a misclassification. Now think about this line, this point. Okay. So this point, according to my line, it is saying that it is not purchased because it is below the line. It is in the not purchase region. So according to my prediction, y predict say it is not purchased. But suppose actually, let's suppose in the data set, suppose it is one, suppose it is purchased. So again, there is a problem, right? There's a, my y predict is saying that it is not purchased. Okay, but y actual says it is purchased. So it's a problem. It is not equal. My y prediction and y actual, there's a gap. It's an error problem. Okay, so this is what I wanted to explain, that these 2 points, okay, this point, this point and this point, okay, there's no error. It is supposed to happen, it is supposed to above the line, okay, actually, and also my prediction line, it is also saying it is above the line, there's no error. And this point, it is supposed to happen below the line, I mean not purchased actually, and even my model is saying it is not purchased, so there's no error. This 2 point is okay, but there's a problem with these 2 points, these 2 points and these points, there's an error. Okay, I hope you're able to understand this. Okay, so now uh, now suppose actually I know that I have identified that these 2 points has some problem. Okay, now let's suppose this point. Okay, actually this point should be above the line, because this point has an error. According to prediction, it is saying that it is below the line, but actually saying it is above the line. So this point should be above the line. I mean, this point should be in this region, in the purchase region. Okay. So what should I do graphically? Just think about graphically, no maths. Just think about graphically. If I want this line, this point into purchase region, okay, how to do that? So let's suppose somehow I can transform this line. Okay, I perform some transformation, some change or some rotation in line, so that suppose I draw a new line like this. Okay, let's suppose if I draw a line like this, a new line like this. Okay, this is my new dotted line. Okay, so you can see that now this point is above the line. Okay, I mean, if I draw this line, I mean, according to my prediction, it is purchased, and also actually it is purchased. So now this point become corrected. Okay, so how it has happened? I just transform my actual line, which was saying it is wrong, into new direction. I did some transformation, I updated something, and now this point got aligned, right, this way. Now this point is saying that it is above the line. This point got corrected. Now about this point, again this point has error. Okay, actually this point should be below this line, right, but it is actually above the line. So again I have to do some transformation, okay, so that it can come below the line. Okay, it can go below the line. uh, yeah, something like that, something maybe something I'm not able to draw like here. Okay, but this is the correct. Okay, so something I have to transform it. Okay, so here what I'm trying to establish the concept here, that whenever you find that your prediction and actual is not equal, if it is equal, then there's no problem, there's no error. But if it is not equal, then I have to do some adjustment. I mean, what, because the in the previous video I discussed, right, your perceptron is nothing but a straight line. You are drawing a straight line. So I have to make some rotation in my straight line so that the point got adjusted. Okay. I'm not saying that all the point will get adjusted. There will be still some misalignment or misclassification. You cannot get 100% accuracy in a model. But this is a model that try to achieve some accuracy, maybe 80%, 90%. Suppose you have 100 points. Out of 100 points, suppose your 90 point got correctly aligned. Maybe 10 points are not getting aligned, maybe because of boundary reason. Okay, so this is what happens. Okay, so here what I'm trying to build the concept here is that if your line representing a perceptron model, and you find that there's some errors, some point are misclassified, we have to rotate our line so that it all the point got fit into the right region. This is the whole concept I wanted to put. Okay, so now here I hope you understand that we have to make some alignment in the line, we have to do some rotation. Okay, so here the another rules. Okay, so now how to align the concept. I think you got the concept that we have to make some rotation. Okay, so there's some rotation rule. Again, this is the math. Okay, there are some rotation rules so that you can achieve that goal. Okay, so my goal is that I have to rotate my line. Okay, so that suppose this point, okay, this point is below the line, but actually it should be above the line. So how I can do rotation? Okay, suppose if I rotate this line from like this, okay, then new line. So according to new line, it will be above the point, above the line. This is what I want to achieve. Okay, so somehow I have to do rotation. Okay, if I'm able to rotate, then I will find the right line and right uh, weight and bias. Okay, okay, so there's some rule here, there's some mathematical rule here that I want to talk about. Okay, then your concept will be simple. Okay, okay, why I'm telling this concept. If you understand this concept, the next part which I'm going to explain become very easy for me. Okay, so that's what I'm trying to explain. Okay, so let's suppose again I'm again drawing that point. Okay, and let's suppose this is my line. Okay, and let's suppose I have 2 points. Okay, I have, suppose I have this point, and so let's suppose this is the error point. Okay, it's a misclassification point. Okay, so now this point is above the line. Okay, now somehow I want that this point should be below the line in this region. Okay, so how to do that? That's what I explain right now. So let's suppose there's some formula for that. Let's suppose for this line, okay, this line is representing like it has some weight and bias. Suppose w1 x1, w2 x2 plus y. This is the line, and let's suppose it has some coordinate. Okay, this point has some coordinate, suppose, and 2 and 3. I'm just giving hypothetically. Okay, so this is my line. Okay, so this line, nothing but it has some, I mean, this, it has some weight and bias. Okay, so if I rotate this line, I mean, I have to change how to rotation will happen. If I rotate the line and this point will suppose come down, I mean, I'm updating my weight and bias. That's what be. Okay, so rotation is nothing but you are updating your weight and bias, and you're getting a new line. Okay, so that this point get aligned properly. Okay, so rotation is nothing but you're updating your weight and bias, so that line get aligned properly. Okay, so the rule says that, see, this point is right now this point is misclassified. Okay, and I want that this point should come below the line, and this is my current setup. Okay, so what I need to do, this point will attract or pull. Okay, this line will, because this is a misclassified point, so this point will attract this line towards itself. Okay, and let's suppose if I move this line to a little bit above. Okay, and let's suppose I got a new line like this, suppose new line like this is the new line. Okay, let's suppose this red one become my new line. So now according to new line, this point is below the line, that's what I wanted to achieve, right? So I got transformed, my line got transformed into new line, which is red one, and this line got pulled or attracted towards the point. The point is above the line, so this line will get attracted towards it. It is getting shifted towards it. Okay, so it is moving up in upward direction. So your line, your real line is moving into upward direction, in the positive direction, because it's a positive reason. Okay, in that case, what happens, how the rotation happens? So suppose I have this my point 2 3. Okay, and let's suppose this original line, let's suppose I'm representing, suppose 2x plus 3y plus 4. Okay, and here x is my first feature, y is my second feature. X is my what is called what is the data, x is my salary, and y is my city. I have two features, right? So this is my okay, so this is my x is my salary, and y is my city. Okay, and 2 and 3 is a bias, a weight. Okay, this is w1, this is w2, this is my line. Okay, and this is my bias. Okay, so the rule says that if you really want to attract or you want to move this line in upward direction toward the point, okay, what you do, you have to do this. So this axis, okay, the coefficient of x is 2, coefficient of y is equal to 3, and the bias constant is 4. I'm taking 2 3 4. Okay, and here in the point you just add 1, so new thing become 2 3 1. Okay, so now it becomes 2, it becomes 3, it becomes 1. Okay, now if you're moving in upward direction, you have to do subtraction. So this is the rule of rotation of a straight line. It's a maths. Okay, by the way, there's no any deep meaning, it's a complete maths. Okay, so if you really want to move the line into upward direction, then you have to do subtraction. Okay, from the coefficient of x y minus the coordinate of the point. Okay, so if you do the minus, it becomes 0, because I have taken very hypothetical number. 2 minus, okay, it become, let me change this. Okay, become 2 4, suppose 8. Okay, so it is 8, it is 4. Okay, and 2 3, so 2 3 1, so 8 minus 2 becomes 6, 4 minus 3 become 1, and 4 minus 1 become 3. So my new line will be 6x 1y plus 3 3. This become my new line. Okay, so from 8x 4y plus 4, my new line become this, and with respect to new line this, okay, this point 2 3 will be below the region, below the line. So this line it becomes this, and this point is below the line. Okay, so this is the rotation rule. This is the math, by the way. Okay, on the opposite, let's suppose I have another point here. Let's suppose, let me give a different color. Let's suppose I have a blue point. Suppose this is the point, suppose -2, -3. I'm just giving a hypothetical, some random value. Okay, -3. Okay, so now according to this line, okay, my prediction is saying that suppose it's a misclassified point, it's an error point. Okay, so according to prediction, it is below the line and purchase not happened. Okay, but actually purchase happened. So I want this line, this point above the line in the purchase region, because above the line is a purchase region, right? So how to do that transformation? So this point, okay, this point will attract my original line towards itself in this direction, in the negative direction. Okay, so if you want to move your line in the negative direction, you have to do positive. Same rule. Okay, the rule is, if you want to move your line, original line, in the positive direction, do subtraction. If you want to move your line in the negative direction, do addition. Okay, again the concept is same. Whatever your coefficient you have at for y, and the point is suppose -2 -3, add it. So 8 minus 2 becomes 6, 4 minus 3 become 1, and 4 minus it is plus 1, 4 plus 1 become 5. So your new line will be 6x, 1y, and 5. So this is the rule. Okay, so rule says, let me write here. So again, this is the math. Okay, I will prove in the mathematically also. So math says rotation formula is this. Okay, let's suppose rule number 1, say you have a line. Okay, and line had, suppose it will have some coefficient, right? Suppose w1, w2, and intercept. This is my line. Okay, if you want to move line movement, if you want to do in upward direction with respect to, suppose, x and y, this is my point. I want to move this point, this line, in the upward direction. It is pulling it upward direction. Then you have to do subtraction. Okay, so x, w1, w2, and b, you will add one other additional point, and you will do x, y, 1 subtraction. This is rule number 1. Okay, and after this subtraction, you will get a new value. It become the new line. And rule number 2 just opposite. Okay, rule number 2 says, suppose you have a line and it has a coefficient w1, w2, and b. Okay, and you want to move the line in the downward direction, and suppose your point is xy. Okay, so the rule says, again the same thing, you have to add. So you have a w1, you have a w2, and you have a weight. Okay, and you will add one number here, so it become x, y, 1, and you will add here. So this become your new line. Okay, so this way transformation happen. Okay, this is the rule. Okay, okay, all right. So this is we established this concepts. Okay, if you really want to, okay, let me give a demo. If you really want to understand this demo, this is a very good tool called Desmos. Okay, let's suppose, let me let me uh, let me prove this. Okay, let's suppose this is my line. I have taken some line 2x. This line is a 2x plus 3y plus. I'm just taking some random line. Okay, anything. Okay, and I have a 2 point. I have a point -2 -2. This is x is equal to -2. This is the point. Okay, this point is nothing but 2 -2, and this is my line. This is my line. Okay, so here, let's suppose this point is a misclassified point. Okay, so you can see that above the region, it's a, suppose I have two region, purchase region. This is the above the line is a purchase region, and below the line is the not purchase region. Okay, so suppose this is a misclassified point. Okay, so my prediction says it is not purchase, but suppose it is actually purchase. So somehow I want to bring this point above the line, in the purchase region. Okay, so this according to the rule what you have learned right now. So this point will attract this line towards itself. So direction will be negative, right? So in the negative direction, what you have to do, you have to add. Okay, so the new line will be 2. My coefficient is 2 3 7, and my point is -2 -2. I will add 1. Okay, so the new let me show the calculation. Let me add it. Let me open a calculator. Okay, so here I will add, right? So 2 minus 2. Okay, so 2 minus 2 becomes 0, and 3 minus 2 become 1, and 7 plus 1 8. So it becomes, okay, so 0. Okay, let me draw this line. Let me draw another line. Okay, my line become like this. Okay, so 2 minus 2 becomes 0. So x becomes 0. Okay, and y become 3 minus 2 1 y, and y plus 1 7 8 equal to 0. Okay, so this is my green line. Okay, you can see that. So red line was my original line, and according to red line, this point was below the line. Okay, now this point, this line, the green line after the transformation. Okay, now according to green line, this point now it is above the region. So according to green line, it is the purchase region. According to red line, it is not purchased, which is wrong. I did a transformation. After transformation, I got that this point is above the line, which is the purchase. This way I did a transformation. Okay, and one thing, actually, let me go there. Okay, here actually one thing we do. Actually, here we are doing one thing. Generally, in the mathematically, we can do this kind of transformation. There's no any problem. Okay, this kind of transformation can do in mathematically, but there's a rule that in case of ML or in case of deep learning. Okay, in case of I hope you know that in case of ML or in case of neural network, this kind of it's very kind of drastic change. If I do this kind of rotation, it's very drastic or very huge change. Okay, generally in ML, in machine learning model, we do a transformation, we do the change, but we don't perform this kind of drastic change. So for that, we take very small step. The change we do, we take very small step. We don't do a drastic change. Okay, so this is called a learning rate. Generally in ML, you have learned the concept. We call it learning rate. So we apply some learning rate. Okay, and it is called eta. We call it eta by this letter. And generally we put eta like 0.001 or zero point 0.1 also, or 0.0001, something like that. Okay, so we take very small step. We don't do this kind of drastic change. If we do a drastic change, there's a problem. It is called gradient explosion, gradient descent, and there's some problem with gradient. Okay, there's problem with optimization. Your gradient will not converge. It will be explode your gradient if you take very high step or big steps. So that is why we apply some small step. Okay, so generally what we do while doing the transformation, let's suppose here, let's suppose for this, suppose number case number 2, I want to bring my line below. Okay, so this is my coefficient, this is my x. So in the x, in this coordinate, I will multiply by eta. Okay, so the eta, which is, suppose I'm taking 0.01, right? So if I apply multiply eta x, so x will become very small because I'm multiplying by a fraction. So let's suppose x is my, suppose 4. Okay, after multiplication by 0.01, it will become what? 4 0.04. Okay, so you can see that from the change, initially it was 4, the step was 4. After multiplication, it become very small. So we take a small step. Okay, because of gradient problem. Okay, so this is what we do. Okay, so we apply some eta here. Okay, so here, this is my formula. I hope now you're able to understand the formula. I had my W1, W2, and my weight. Okay, and it has my coordinate like x, x1, I mean the coordinate is the my feature. Okay, let's suppose okay, let me put this way. Suppose this is my data, my salary, my city, and my prediction, my purchase. This is my data. Okay, so w1, w2, and weight, this is the let's suppose I have input, suppose 2 and 3, and purchase happen. Okay, so for this 2 and 3 I will assign them weight, which is nothing but w1, w2, and I have some bias. Okay, and my actual point is 2 and 3. I'm calling it x1 and x2. So this is my x1 and x2, and I'm adding n1 here. Okay, so here, in case of this case, suppose I'm moving into this direction, I'm moving into downward. Okay, then I will add. Okay, the rule says I will add here. Okay, so here now, after adding, what will happen? W1 will happen what? W1 plus, and suppose I'm multiplying by eta. Okay, so it become W1 plus eta into x1, right? And W2 will become W2 plus eta into x2, right? And B will become B plus eta into 1. You can see here now my W1, according to this rule, okay, my W1 got updated, my W2 got updated, and my bias got updated. So this way I got some transformation. Okay, according to this rule. Okay, now let me, if you understand this whole concept, so this is what how the transformation happened. Let me summarize again. uh, Only thing I want to establish a concept here graphically. Okay, that we have a straight line, and maybe my prediction is wrong. Okay, if my there's some error point, I call it error point, then we have to shift our straight line. Okay, so that my points got aligned, my prediction got corrected. And how we do that? We perform this, it is called a rotation rule. We perform this rule. Okay, and this way my line got shifted, and my points got, what was the error point, got aligned properly. Okay, I took a lot of time, I know that, but it was very essential, it was very important to establish this concept, this rotation formula. Okay, and after this rotation I came to know that my weight got changed.